Today we're going to begin Unit 4, which is on stoichiometry. But before we get into what that is, we need to talk about how to balance equations and how to write reactions. So that's what today is going to focus on. So some of this is a little bit of review. You might remember some of these definitions and some of the things about chemical reactions, but a chemical reaction is the process by which the atoms of one or more substances are rearranged to form different substances. So you're starting with one or more things, changing to one or more different things than what you started with. Some evidence of a reaction. This is, remember, we made a list of this back in Unit 2. So this is not exhaustive, but this is sort of some of your more obvious things, is if you absorb or release heat, and not the result of just heating something up to watch it boil, but you've added two things together, and it lets off heat or gets very cold by absorbing heat. A color change is a good one. Odor, if it's producing a gas, if you add two things together and it starts to bubble. Or formation of a solid, which you might remember back from Unit 2, this was called a precipitate. Seeing if you remember any of the vocab words there. Okay, so parts of a reaction. We have the reactants, which are the starting substances, and the products, those are what you end with, the resulting substances. You don't write an arrow in between them because they're not equal. It's one thing becoming something else. You're not going to end up with what you started with. So instead of drawing an equal sign, you draw an arrow between each side of the reaction. So over here are your reactants. They're on the left. And on this side, you have your products. Notice here, there's 2 and 2. You got 2 reactants and 2 products. That may not necessarily be the case. You could have 1 reactant and 2, 3, 4 different products. You could have 2 reactants and 1 product. They could combine to form them. Okay, so you're not limited to just 2 and 2. You could have different numbers on each side. Don't forget, we have to indicate which state of matter things are in. We've seen this before, but just drawing your attention back to it. So S was solid, L was liquid, G is gas, AQ means aqueous, which was dissolved in water. Over here on the right-hand side, some more common symbols that are used in reactions. Plus sign separates 2 or more reactants or products. The arrow separates the reactants from the products. This we're probably not going to see too often if you go on and take AP chemistry and talk about equilibrium. You'll see reactions that can be reversed. They can go both directions. And then down below there, of course, we've got our states that are also on the left-hand side. So, consider the following reaction between aluminum and bromine. Okay, so it could say, and you'll see these on the homework for tonight, it could say something like aluminum plus bromine yields, change that over, yields aluminum bromide. Okay, aluminum and bromine react to produce aluminum bromide, and that's all it says, and it wants you to write a reaction from that. Okay, so you are going to write what is called a skeleton equation, and this is just using the symbols and what you know about the states of matter of those things to write a reaction. It is not necessarily balanced. We will do that later on. If it tells you to balance it, then balance it. Otherwise, it just wants the basic what is happening here. Give me the formula for these things. Okay. Skeleton equation. So example here is, let's say we have aluminum, and we're reacting that with bromine, solid aluminum, plus bromine. Don't forget, bromine is a diatomic molecule. Remember, it's one of the 7. H2N2, O2, F2, Cl2, Br2, and I2. Don't forget that. Okay, those are diatomic. So whenever it says liquid bromine, it's not talking about simply just Br. It is bromine bonded to itself, Br2. Okay, so that's the liquid there. Is going to yield, and this, on the other side here, aluminum bromide, AlBr, and this 3 should be a subscript. Okay, it's going to yield aluminum bromide. How do you know that that's the formula? Well, you have to remember, and you need your ion sheets if you can't remember. Aluminum forms +3 ions. Bromine, when it forms bromide ions, each is -1. So you need 3 bromines to counter the fact that aluminum is +3. The formula for that is AlBr3, and it is a solid. Okay, the second one here, you got solid carbon, so that could be graphite or charcoal or diamond, but probably not in this instance. Plus sulfur, which is a solid, is going to yield, this is carbon disulfide, CS2. Okay, carbon disulfide. So those are not balanced. They're simply just what are the reactants and what are the products. That's all it's telling you. Okay, so it says down here, note these equations are not balanced. There are 2 bromines here on the left-hand side of this top one. So Al plus Br2, so there's 2 bromines. And on the right-hand side, we have 3 bromines. So you got 2 here and 3 here. Well, if it were balanced, you'd have the same number on each side. And then on the second one, notice here there is 1 sulfur, and on the right-hand side there are 2 sulfurs. So we have to have those balanced in order for this to work. Okay, so for a chemical reaction to be useful to us, it's got to be balanced. Okay, we have to have things balanced. Means you have to have equal numbers of atoms on both sides of the equation. So consider that reaction that we've been looking at here. I hate how this thing always undoes the formatting I put into it, but whatever. Okay, so we consider the reaction we were looking at before. Aluminum plus bromine yields aluminum bromide. Okay, well, what does that mean? We've got 1 aluminum atom coming from right there. We've got Br2, notice it's bonded to itself. Okay, and over here we still have 1 aluminum atom in the middle, but the 3 bromine atoms are now bonded around it as bromide ions. Well, we don't have equal numbers of things. I mean, in total we have 1 aluminum and 2 bromines. Here we have 1 aluminum and 3 bromines, so we need to fix that. Okay, and this all goes back to the law of conservation of mass, and that is to say that the mass must remain constant throughout the reaction. So in order to balance it, you have to add coefficients. You have to add coefficients. And it says usually whole numbers. I'm going to go ahead and just cross that off and say, for our purposes, they are always whole numbers. If the value is 1, you leave it off. Okay, so you do not write the number 1 if it's just 1. And these reactions represent the lowest whole number ratios. So if you give me like 4 to 8 to 4, I'm going to tell you that that should have been 1 to 2 to 1. Okay, you can get by with this. It'll work with what we're going to do in stoichiometry in the next few sections. But technically it should be written like this, and it actually will make your life easier to try to figure out. So it's got to be in the the lowest whole number ratio. All right, so down below, this is just giving us an example here of what this would look like. Here was our skeleton reaction. Okay, here, this is when it is balanced. Okay, I have put a coefficient in front of the aluminum, a coefficient in front of the bromine, okay, draw my arrow, and a coefficient in front of the aluminum bromide. I'll go ahead and box them so they stand out to you a little better. So what does that mean? That means that anything that directly follows it is now multiplied by whatever number is out front. So here, I now have 2 aluminums. Here, I've got 3 times 2, so I've got 6 bromines. So here I've got 2 aluminum, and I've got a total of 6 bromines on the left-hand side. Now, over on the right-hand side, the product side, okay, again, this 2 gets distributed amongst everything over here. So I now have 2 aluminums and, 3 times 2, which is 6 bromines. Okay, so I end up with the same amount of aluminum on each side and the same amount of bromine on each side. Yes, this one isn't a compound and these ones are in their elemental form, but that is okay. We don't have to worry about that. We just want to know if the total number of atoms are the same, because the law of conservation of mass must be correct here. Okay, we can't gain or lose mass. What we start with is what we have to end with. Okay, so this is just a nice little visualization of what I was just talking about. Here's the unbalanced reaction over here on the left, and after we have balanced it, and I'll show you the process of how do we know, that this number is a 2. How did we know this number was a 3? How did we know this number was a 2? I will show you that process in just a moment. Okay, so 6 steps to balancing chemical equations. Step number 1 is to write the skeleton equation for the reaction. All right, so if you're given that, great, then you don't have to do that. If not, if you're just given a statement, then you've got to convert that from words into a reaction. So this one says hydrogen gas and chlorine gas yield hydrogen chloride. Yield just means produces. Okay, yield means produces. All right, so if we're converting this into a chemical reaction, hydrogen gas, remember, is diatomic. This is H2 gas, so it's going to look like that. Okay, plus chlorine gas is also diatomic, so it's got to be Cl2. Don't forget that, because I say it now, and some of you are going to forget that until you make enough mistakes. You eventually figure it out. Okay, yield hydrogen chloride. We haven't seen this before. It's sometimes called hydrogen monochloride. Hydrogen chloride is a gas, very toxic, HCl. Also forms hydrochloric acid. Okay, so that's what our skeleton reaction looks like. We got H2 gas plus Cl2 gas gives you HCl gas. Okay, so that's what our skeleton reaction looks like. Now I need to count the number of atoms of the elements in the reaction. Okay, so what I like to do is just kind of draw a line in between it, wherever that might be. So we'll put it like right there. In fact, we'll just change the color so that it stands out very nice and clearly. Okay, so the difference between the reactants and products. All right, well, over here on the left-hand side, we have a total of 2 hydrogens. And from right here, we have 2 total chlorines. Notice we don't have any coefficients out front. If we come over to the right-hand side, HCl means we have 1 hydrogen and, not 2, sorry, 1 chlorine. So we do not have equal amounts, which means this is not balanced. We need to take care of that. Okay, so we did steps 2 and 3 together pretty much. We had, again, 2 hydrogens and 2 chlorines on the left. We had 1 hydrogen and 1 chlorine on the right. Okay, step 4 is to change the coefficients to make the number of atoms of each element equal on both sides of the equation. So, if we have 2 hydrogens and 2 chlorines on the left, and we have 1 hydrogen and 1 chlorine on the right. Now we need to take a look at, okay, out front of the skeleton reactions, where can I put a coefficient such that I end up with equal numbers of these things? Well, first of all, I've got less on the product side, so the number's likely going to need to get changed over there. Sometimes you change both of them, but more than likely you're going to have to change the one that's got the smaller amount. So over here we've got one of each, which means we're probably going to have to adjust the coefficient in front of the HCl. So it's not going to be 1. Well, if I put a 2 there, like they've done, I now distribute that 2 to everything in there. I've got, instead of 1 hydrogen, okay, I now have 2 hydrogens. And instead of 1 chlorine, I now have 2 chlorines. And this is what we are going for here. We want to end up with equal numbers. So now you write the coefficients in their lowest possible ratio. For this one, it's 1 to 1 to 2. So 1 here, again, if there's nothing, that means 1. If there's nothing, that means 1. And then the 2 is in front there. And lastly is just to double check your work. Okay, this one was simple because there were only 2 different elements and we were only dealing with 1 or 2 atoms at a time. It can get a little bit more complicated than that. So make sure you're checking your work at the end. All right, an example problem for us. Let's go ahead and change this back to, there we go. Okay, draw our arrow in there. Somehow this aqueous got put on the second line. Let's draw it back up here. Okay. So we've got, this is sodium hydroxide plus calcium bromide. Fix the 2 as well. Okay, yields calcium hydroxide, is that one's name, and sodium bromide. Okay, so what we want to do, once we've already got our skeleton reaction, so that part is done. Let's count up the number of each element, number of atoms of each element on the reactant side. Well, we've got, let's see, 1 sodium, we've got 1 oxygen, we've got 1 hydrogen, we've got 1 calcium, and 2 bromines. And on the product side of things, okay, we've got, let's see, 1 sodium, and we'll try to keep everything together here. 2 oxygens, 2 hydrogens, calcium-wise we have 1, and bromine-wise we've got 1. Okay, a little piece of advice as we start to go into the balancing of things. Okay, and you'll want to jot this down for sure because this will help you out. When you're trying to figure out what to start with in balancing and adding numbers as coefficients, do not start with oxygen or hydrogen unless you have to. They are usually the last things to get balanced. You're better off starting with the other elements, saving oxygen and hydrogen for last. Sometimes, on occasion, you will have to do it first, but more than likely, it will be the last thing you have to balance. So, taking a look at this, all right, so we're going to ignore that for the time being. Everything else looks the same except for bromine. Okay, so I'm going to write my reaction down below. I've got NaOH, and to save space, I'm not going to write all of the states here. CaBr2 yielding some amount of CaOH2 plus some amount of sodium bromide. Okay. Well, we said before, whichever one is the smaller amount, that's likely going to be the coefficient you have to change. Well, where is the bromine on the right? It is over here. So we're probably going to have to change this. Well, in order to get to, what coefficient could I put there instead of a 1? Well, I'm going to write a 2 there. And now I end up with 2 bromines on the right, but this 2 also adjusted the amount of sodium. So don't forget that part. Now we ended up with 2 sodium atoms. Now my sodiums are not adjusted properly, so I got to fix that. So that means that this one, that's the smaller amount, we're probably going to have to change. Well, to get 2, let's find sodium down here. Okay, there's 1. I need to get this to 2 sodiums. To do that, I'm going to put a 2 in front of the NaOH. Okay, now that also changed the amount of oxygen and hydrogen. Okay, this is now times 2 as well. So now I've got 2 oxygen and 2 hydrogen. Now let's just pause to see if we're in a good spot. We've got 2 sodiums, good, 2 oxygens, check, 2 hydrogens, check, 1 calcium, and 2 bromines. So we are all good there. Okay.